Hi everyone. So our next topic is scientific notation. And if some of you have already had your science course or will be taking a science course soon, whether it's physics or chemistry or biology, you will very likely encounter scientific notation. However, scientific notation doesn't have to be used for science. Really, what it's useful for is representing either really big numbers or really small numbers. Right? So this is what it's useful for. Right, so any number can be represented in scientific notation. It's just that in some cases it's not really necessary, right? All right, so what is scientific notation, right? It's just a way to rewrite numbers, right, using powers of 10. So, right, instead of writing the number 1,000, right, I can write that number as 10 times 10 times 10, or better yet, 10 to the power 3. Right? If I want to write the number, let's say 40,000, well, that's 4 times 10 times 10 times 10 times 10, which is 4 times 10 to the power 4. Right? If I want to write the number, let's say 320,000, right? I can write that as 32 times 10 times 10 times 10 times 10. Yeah, 4 zeros, right? So this is going to be 32 times 10 to the power 4 again, right? Okay. So all of these numbers, except for the last number, this number is not in scientific notation. Not yet, anyways. And so in scientific notation, what you're looking for essentially is just a single digit. I'll call it A, right? And then the decimal place, and then the decimal, and then a bunch of other numbers, right? C, B, D, E, F, G, whatever they are, right? And then we multiply that times 10 to some power, let's say n. Okay, so the important thing is that this A here is a single digit. Single digit, and in fact it can't be 0, so a single non-zero digit. Right? So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. Right? So the problem with this 32 times 10 to the 4, right, and then you can have as many zeros here as you want, is that this has 2 non-zero digits in front of the decimal. So you're only allowed 1 digit, right? So what we can do is just divide this number by 10, as long as we also multiply by 10, right? You could cancel the 10s, and then you're back to square 1, right? So when we divide this by 10, we get 3.2, right, times 10 to the power, well, now it's no longer 4, right? It's 4 plus 1, which is 5. Okay, so the number 320,000, right, you can write in scientific notation as 3.2 times 10 to the 5th power. Okay. Right, and you might think, what's the point of that, right? I'd rather just write out 320,000. And that's fine for most numbers like this, right? But in science, and in fact in life in general, numbers are not always going to be that small. They could be a lot bigger, right? So for example, let's talk about the age of the universe. The age of our universe, as best as we can tell, is approximately 13,700,000,000 years old. Okay, so that's a pretty big number, right? It's a very old universe. That's relatively speaking, I guess, right? So yeah, so this being a very big number, this would be more conducive to writing in scientific notation. So how would we write this using scientific notation? Right? And the idea is, right, to just represent this as powers of 10, right? Every time you move the decimal, and let me just copy it down. Every time you move the decimal, right, you're either increasing or decreasing by a power of 10. I think I have enough zeros here, right? Yeah. So the decimal right now is at the end, way over here, right? So how many times do we need to move it? Well, we need to move it so that we get one digit in front. That digit would have to be the 1, right? So we're going to get 1.37 times 10 to what power? So just move the decimal, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we move the decimal 10 spaces, 10 times. So this is going to be 1.37 times 10 to the 10. Right? In years. That's the age of the universe in years. Okay? Right. So, again, that's just slightly more convenient than writing out 13, right, comma 700000000. Okay, so numbers get even bigger than that, of course. And so here's a good example of that, right? The number of, let's say, molecules of gas in your room, right? Wherever you are right now, you're in some room, presumably. If you're outside, of course, then this may not apply, because then you're talking about the entire atmosphere of the Earth. But let's say the number of molecules of gas, right, in a typical room, in a typical sized room. And of course, it depends on how big the room is, but right. So that number is going to be approximately this number here, very roughly, right? It's going to be 6 and then 602. I think it's quintillion, and then 200, 000, 000, 000, 000, 000, 000, 000. I think that's it. Yep. So this is a very big number, right? It's a huge number. It's a lot of molecules of gas, right? So we're talking about oxygen, nitrogen, carbon dioxide, right? These are typically, molecules of gas that are in the room. So again, not very convenient to write out all these zeros, but this is where scientific notation really comes in handy, right? If we want the decimal to be just after the 6, we get 6.022 times 10 to what power? So just move the decimal, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So the exponent of 10 is 23. Okay. And this is actually a very important number in chemistry or physics. It's called Avogadro's number. Avogadro's number. So if you take chemistry, you will very likely see this number, right? And again, it's a rough estimate, right, for the number of molecules of gas in a typical room. Okay, so yeah, very big numbers, much more convenient to write out using scientific notation. Right? Rather than, we'll just call this standard notation. Right? Standard number, standard decimal number. Okay. Of course, it can also be used for very small numbers, right? So typical small number, well, let's use the size of a typical coronavirus. So a typical coronavirus is about 125 nanometers. And if you were going to write this out, this would be approximately 0.000000125. So I think that's it, right? So yeah, a very small number. Oh, and this is in meters, right? This is in meters. Well, so how would we write that in scientific notation? So we want to move the decimal, this time going the other way. We're going to move it to the right until we get the 1, right, in front of the decimal. So this will be 1.25 times 10 to what power? Okay, so we're moving the decimal, let's see, 1, 2, 3, 4, 5, 6, 7 times. So it's not 10 to the 7, it's 10 to the negative 7, right? So yeah, for small numbers, right, you're going to get negative exponents. Right. For big numbers, up here, for big numbers, you get positive exponents. A little sloppy, right? Is that okay? Yeah, so negative exponents, right? Now I know in the last video you said, wait a minute, I thought you told us we're not allowed to write negative exponents. Well, no. So if you have x to the negative 7, no, you have to rewrite it as 1 over x to the positive 7. Okay. But yes, so this is sort of the exception to the rule, right? In scientific notation, you are allowed to have negative exponents. Okay. And this is a good example of that, right? So yes, either very big numbers or very small numbers. But the point is you can write any number in scientific notation. So let's just look at some examples, right? So the number, 28,600. Okay, nothing wrong with writing that as a number, but what would this be in scientific notation? Right. Well, okay, so let's write the number out in standard notation. The decimal's at the end here, right? And since this is a big number, right, we're going to write it as times 10 to some positive exponent. What is that exponent? Well, let's see. Where do we want the decimal to end up? We want the decimal to end up right after the 2, right? Right here. So we move the decimal 1, 2, 3, 4 spaces, right? So we're going to end up with 2.86 times 10 to the power 4. Right. And we've seen 4 a lot, right? But that's just a coincidence. Right, so let's pick a bigger number. How about 742 billion? That's million, that's billion, right? Well, we want the decimal to be right after the 7, right? So this will be 7.42 times 10 to what power? So we move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces, right? So 10 to the 11. Make sense? Yeah, so that's all it is, right? How about a small number? How about 0.00000000014? Okay, so remember for small numbers, we need a negative exponent. So times 10 to the negative what? Well, we want the decimal to be right after the 1, right? So 1.4, oops, make that a little bit bigger here. 1.4 times 10 to what power, right? So we move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So 1.4 times 10 to the negative 9. Oh, and this is not an x, right? This is just the time symbol here. So sometimes I'll use a dot to represent multiply. And as long as it's not confusing, a little x can also mean multiply. Okay. Right, so yeah, small numbers get negative exponents, big numbers get positive exponents. Right. And of course we can go the other way. Right? Suppose we have a number in scientific notation, about 2.089 times 10 to the 6, right? What would that number be in standard notation? Right? So we're going from scientific, right, to standard. Scientific, right. Right. Well, so this is going to, since we have a positive exponent, it's going to be a pretty big number. We start with the 2, and then we move the decimal 6 times to the right, right? So 1, 2, 3, 4, 5, 6. And then we typically put commas every 3 digits, right? So this number is 2,089,000 in standard notation. Right? Let's do the same thing with, how about a small number? 8.107 times 10 to the negative 14. Okay, so this, again, this is in scientific notation. Right? And we want to rewrite it as a standard number, a standard decimal number. So what would that look like, right? So because it's 10 to the negative 14, this will be a small number, right? You're going to get 0.0 what, right? So actually, I would start with the 8.107. The decimal is right here, right after the 8. Where do we want the decimal to end up, right? So 14 places, but we have to move to the left, because if we move to the right, we're going to get a big number. We want to get a small number. So we move it, let's see, once, and then again, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then we have the decimal point, right? Yeah, make it a little bit bigger. So I think that's it, right? I think we get 13 zeros, right? And then the 8107. So erase that. And there's our decimal number. I typically put a 0 in front, although you don't have to, as long as the decimal is big enough to see. So I'm going to double check, make sure I have 13 zeros after the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And then 14 to get the decimal after the 8. Oops. Sorry about that. All right, so, right. So going back and forth between scientific notation, standard notation, hopefully you can get used to that. But something else you might have to do is actually calculate numbers, right, using scientific notation. So let's start with a simple example, and then we'll get to the more difficult ones later, right? Suppose we want to calculate, let's say we have 3 times 10 to the 8, and then we want to multiply that times 7 times 10 to the 4. Okay. Now, the way you don't want to do it is convert to standard notation, right? You want to calculate and write in scientific notation. Okay. Right. I mean, the point is we could write this out, right? This is 3, 1, 2, 3, 4, 5, 6, 7, 8. And then 7, 1, 2, 3, 4, right? And then multiply these two numbers and then put it back into scientific notation, right? But that's the hard way. That's the long way. Here's the easy way, right? We're really just multiplying 4 numbers, right? 3 times 10 to the 8 times 7 times 10 to the 4. So if I just switch the order here, I can write this as 3 times 7 times 10 to the 8 times 10 to the 4. Well, what's 3 times 7? Right, 21. What's 10 to the 8 times 10 to the 4? Well, we have the same base, so it's 10 to the power 8 plus 4, right, by the exponent rules that we learned in the last section. And 8 plus 4 is 12. Right? So we get 21 times 10 to the 12. Times 10 to the 12. But remember, that's not scientific notation, right? Because the decimal point is after the 1. So we need to move the decimal to the left one space, right? Because we want 2.1. 2.1, right? Times 10 to the what? Well, by moving the decimal to the left one space, we effectively divided by 10. So we don't want to divide the number by 10. We want to divide the number by 1. But if you multiply by 10 and divide by 10, yep, the 10s cancel, right? So by multiplying, by another 10, we increase the exponent by 1, right? 12 plus 1 is now 13. And I didn't mean to use green. 10 to the 13, right? So there we go. This number is just 2.1 times 10 to the 13th power in scientific notation. Okay. So yeah, be careful not to leave the answer like this, 21 times 10 to the 12, right? Because this is not scientific notation. Okay. I mean, it is correct. It is equivalent to this number here, but it's not in scientific notation. The directions clearly say write in scientific notation. Okay. So yeah, so let's do a few more examples. Okay, next example, right? We want to calculate and then write in scientific notation. 4.2 times 10 to the 27 divided by 8 times 10 to the 6. Okay. So the way we did it when we multiplied is we separated the digits, right? The 4.2 divided by 8, we can calculate that. And then times 10 to the 27 divided by 10 to the 6. Okay, so 4.2 divided by 8, you can use your calculator if you want. It's 0.525. Just making sure. All right. And then times what? Well, times 10 to the power 27 minus 6. Right, which is just 10 to the 21. Right, so 0.525 times 10 to the 21. But again, that's not scientific notation. Remember, this digit here cannot be a 0. Right? It has to be a 1, 2, 3, 4, 5, 6, 7, 8, 9, but not a 0. So what does that mean? It means we need to move the decimal. But this time, we're going to move it the other way. We're going to move it to the right. Right? So what we're going to want is 5.25 times 10 to the what? Okay. Well, right, when you move the decimal to the right, you're multiplying by 10. Right? So I can multiply this by 10 as long as I also divide by 10. Think of that as 10 to the 1, right? So I multiplied by 10 and divided by 10. So now, 10 to the power 21 minus 1, right? Which is just 20. And there it is, right? So that's the answer. This equals 5.25 times 10 to the power 20. So, yep, whether you're multiplying or dividing numbers in scientific notation, right, very often you have to be careful and you might have to move the decimal 1 or 2 more places. Right. All right, so try this one. Okay, multiply and write in scientific notation. 2 times 10 to the negative 16 times 4 times 10 to the negative 33. Got it? Yeah, this one should be kind of an easy one, right? This is just 2 times 4 times 10 to the negative 16 times 10 to the negative 33. All right, so 2 times 4 is just 8, right? And then this is 10 to the, well, negative 16 plus negative 33, right, is going to be negative 49, I think. So 8 times 10 to the negative 49. Right? And that's it, right? So the decimal is after the 8. There's only one digit. We don't have to do anything to this, right? So yeah, you just leave your answer in scientific notation. Again, negative exponent, but that's okay when you're dealing with scientific notation. Right. Try this one. Okay, so here we're dividing, right? 3 times 10 to the negative 120 divided by 4 times 10 to the negative 20. Okay, so this one's not going to be quite as simple. Okay, so we can still split up, right? The 3 over 4 times 10 to the negative 120 divided by 10 to the negative 20. Okay, so the 3 over 4 is just 0.75, right, as a decimal. And now we have to be careful here, right? This is going to be 10 to the power negative 120 minus negative 20. So it's really negative 120 plus 20, right, which is negative 100. So 0.75 times 10 to the negative 100, right? It's not negative 140, right? You're subtracting a negative. So it's negative 120 plus 20. So you get negative 100 for the exponent, right? Messed that up. Right. So that's just for the exponent. Okay? Right? However, we're not in scientific notation, right? You cannot have a 0 in front. This 0, right, should be a 7. So we're going to have to multiply by 10 to move the decimal to the right, right? So multiply by 10 and then divide by 10. So if you multiply by 10, this becomes 7.5, which is where we want the decimal. And now when we divide by 10, we take negative 100 and we subtract another 1. Negative 100 minus 1 is negative 101. Right? So 7.5 times 10 to the negative 101. Right? And so that's the answer. I'll just write it up here. Sorry, negative 101. Okay, so I hope that helps, right? Yeah, so again, these are really, really tiny numbers when you have exponents that are that big, you know, almost unrealistically so. But yeah, sometimes we use either really big or really small exponents like the negative 120 or positive 120, right? Because you might have noticed that some of these can be done on the calculator, but if you try doing this on the calculator, it's not going to work, right? It's going to give you an error. So, right, so the answer is not that there's an error, it's just that the calculator can't handle exponents that are that small. Right. Or it might give you 0, right? I assure you, this number is not 0. It's not equal to 0. So if you put 0, it's wrong. The problem is that this number is so small that it's the calculator, for the calculator, it's almost indistinguishable from 0. Right? It might as well be 0. So it's approximately 0, but not exactly. Right. So I hope that helps. All right, last one. one more. Okay, so multiply 4.1 times 10 to the 25 times 3.5 times 10 to the 85, right? And as always, write it in scientific notation. All right, let's see how you did. So as usual, just multiply 4.1 times 3.5, and then times 10 to the 25 times 10 to the 85. Okay. So 4.1 times 3.5 is 14.35. Right? And 10 to the 25 times 10 to the 85 is 10 to the power 25 plus 85, right, which is 110. And again, we're almost done. We're not done because this is, right, this is not scientific notation. You cannot have two digits in front of the decimal. We need to move the decimal once to the left, and that means divide by 10. And we can keep it the same number as long as we also multiply by 10, 10 to the power 1, if you like. Right? So this becomes 1.435 times 10 to the 110 plus 1 is 111. And there we go. So I hope this gives you, right, enough information to be able to do all the problems in this section, right? Again, some of them are just going to ask you to convert from one to the other. And in some cases, they're going to ask you to either multiply or divide numbers. And then this is where you might have to use this trick of multiplying or dividing by 10. Okay, so you don't always have to do it. We didn't have to do it in this first example. But many of these examples, you do have to move the decimal maybe one or two more times. Okay. Okay, so maybe just try these three. And if you can handle these three, you could probably do just about any of the homework problems. Right? So write a number in scientific notation, 0.0000507. You just move the decimal to after the 5. So 5.07 times 10 to what power, right? Negative 1, 2, 3, 4, 5, 6. Yep. So 5.07 times 10 to the negative 6. That's all it is, right? So if your number is already in scientific notation, you want to write it as a regular decimal number, well, just move the decimal, right? So 9.308. So we moved it 1, 2, 3, 4, 5, 6, 7, 8 times, and then the decimal. Right. So I'll put a comma every 3 digits. So this number, 9.308 times 10 to the 8, in scientific notation, as a standard number, it's 930,800,000. Right. And finally, when you want to divide, say 1.2 times 10 to the 30 divided by 5 times 10 to the 7, it's 1.2 divided by 5 times 10 to the 30 divided by 10 to the 7. So 1.2 divided by 5 is 0.24, and 10 to the 30 divided by 10 to the 7 is 10 to the 30 minus 7, which is 23. Right? However, we can't leave it like that, right? We have to move the decimal once to the right, so that means we multiply by 10 and divide by 10. So multiplying by 10 gives you 2.4, and then dividing by 10 gives you 23 minus 1, right? So 10 to the 22. Okay, so that's our answer. 2.4 times 10 to the 22. So I hope this helps.